Welcome back, students. Now in this video we are basically continuing working with our introduction to JavaScript and how to work it in Google Earth Engine, and I'm going to tell you now how to compute NDVI, normalized difference vegetation index, which is one of the most common functions in remote sensing. But also what is important, it also will show you how to perform mathematical operation on raster data sets in Google Earth Engine. So let's start it. Here we are working with Las Vegas, with in the US. You can also change it to any other area you would like. And after running this piece of code, the output is NDVI image. Which we can also change the visualization. So here you can see it's from 0 to 1. So you can, if you want, you can change this, but you can also select a palette. Possibilities to compute NDVI in Google Earth Engine. So first of all, we again working with our image collection. We filtered it by date and by geometry, and we also working with the same composites as in a previous example. And there are different methods how you can compute basically NDVI or any other vegetation spectral index, or perform any other calculation on raster data set. The first method, which is probably the one which is very straightforward, is to declare a variable for those bands that you are interested in. As you remember, NDVI is computed from near infrared and red bands. So near infrared minus red divided over near infrared plus red. This is a formula for NDVI. And basically here we declare the variable B5, which is near infrared. We are selecting it from this composite. Then we declare a variable which is red, and we compute NDVI by writing how it should be computed. So basically here, as you can read, it's a formula of NDVI that I have just told you about. The method 2 is a different one. Well, since NDVI is such a common function, operation, mathematical operation, the developers in Google Earth Engine wrote a function for it, which you can call and apply to your composite. So what is here is basically our function, which is applied to our composite. Yeah. And here in the brackets we specify bands on which have to be passed to the normalized difference vegetation function. Why it is important? Why should we specify the bands here? Because we have different sensors. So Landsat 8 have band 5 as a near infrared, while Landsat 7 have band 4 as near infrared. So you have to specify the bands correctly. And the method 3, which is probably the most elegant one, especially if you have a big pieces of the codes of the script, is to use again a function which is called expression. And in this expression function you can basically write whatever expression, mathematical expression you want. Therefore it could be useful. So basically here the arguments to this expression is a formula that you specify, and then you pass to your function a dictionary where you basically declare what are those arguments. Yeah, so you have a keywords that I mentioned here, and then you pass arguments to all to each of these keyword. Then we have map add layer function. You already know this function. So again, if you don't know what kind of values to use, you can use the default, and then here change them if you want. Yeah, but those are correct values, because as you remember, NDVI has values from 0 to 1, well, and negative, it could be also negative for water. So basically if you want to not to exclude water, then you have to also, you can also change range of NDVI from -1 to 1, and then the values for water could be not ignored. And you can also use different stretching functions. Yeah. Okay, and this is map center object is basically the function that allows us to center our map on the object and vector geometry object that we are working with, so that we are not searching in the map where is our study area located, but by default our results will be centered over our study area.